recording and then so if you have any questions, and you probably will have some questions during this lecture, just type them in the chat window. And I'm recording this lecture, so it will be provided later for you or for anyone who's not present at the moment. But if you type in any questions in the chat window, those won't be visible in the recording, and your name or the question won't be visible. So just feel free to ask anything you want, hopefully about the course. But yeah, so let's start. So welcome to Introduction to Programming, or welcome to Introduction to Programming. So basically what we're going to do today is go through or discuss all the practical stuff about this course, on how to complete it, and where are all the materials and where are all the exercises, and how can you get assistance if you encounter any problems and things like that. And so, as I said, if you have and when you have any questions, just type away. So if we start with the basic facts, which you probably all know, you get 5 credits for completing the course. We start today, and this introduction course will last for 7 weeks. Then there's a 1-week break, and then I think most of you will continue with the advanced course. And basically this introduction and the advanced course actually are like one big course, which is just divided into 2 parts because of practical issues. So we have one sort of a lecture per week. It's Tuesdays at 12:15. There was a second time on Thursdays listed earlier on the course page, but we won't be using that. We won't really need that. We have one lecture, and the lecture is in Codas because I try to. Well, this first one is different. This is basically like a lecture, but in the latter lecture times I show you a lot of examples, and then you hopefully ask questions, and then I have some kind of outline for those, but basically I try to show you things you want me to show you, and we try to discuss things you think or you feel are important and things like that. Let's see how it goes. It's usually, although they are online, they've been usually quite interactive. And also the reason why we're doing this online is that I am showing a lot of examples, and instead of watching me, I think it's more beneficial if you see my screen and see the editor window and things like that, and that's easier when you can follow it on your own computer. Then in addition, we have some workshop times. Let's discuss those a little later. The basic idea is that you can go to workshop and you will get assistance if you have any problems with the material or with the exercises or with anything. You can also participate in workshops online, and there are also some online only times, but I'm going to discuss those later. Anyway, basically the focus is on independent work, and it doesn't mean you need to do everything by yourself or alone. You can work with other people and you will get assistance when required, but it basically means that you don't learn how to program by listening someone talking. You learn how to program by actually typing programs yourself. So that's what we're going to concentrate on this course. And as I mentioned, you will get assistance when needed. We have a lot of teachers participating in this course. My name is Erkki Kaila, and if you want to reach me, email is probably your best option. So just use erkki.kaila@helsinki.fi. This can be found in the course page, for example, and in the material as well, I think. And then there's a more like general address. If you have any issues about the material or exercises or things like that, you can use this. So it can be a sort of a difficult address if you're not Finnish, but this ohjelmoinnin@helsinki.fi. Anyway, it's probably easiest to copy and paste it. If you find any problems with the material, and if you're familiar with things like Git or pull requests, then you can use those as well. If you don't know what those mean, then it doesn't really matter. Those will be discussed later in your programming career. I have an office in Exactum with C213, but I'm really rarely there. If you want, you can take a look. If I'm there, I probably will have time to talk to you, and it's always nice to meet people face to face. But I'm mostly working from not outside Helsinki, so I won't be there that often. And the same applies to my phone number. I do have a phone, but because I don't really use it, it's switched off most of the time. So email and Discord work really well if you want to talk to me as quickly as possible. That is. What are we doing in this course? We are learning the basic programming concepts using something called Python as a programming language. And then, as I said, most of you will continue in the advanced programming course in the second period. So that's, and if we go into more details, this is basically what we're learning. In this first week, we start, well, this is the course introduction, and I won't be talking about actual programming in this lecture, and the reason for that is that the material we have designed it so that it's sort of like it's supposed to be a good introduction to the programming. I think it's important that when you hear the first topics, you get to writing your own programs as quickly as possible. We're going to take a look at that in a moment. And that's why this first lecture is basically just about the course practicalities. And then on the upcoming weeks, we're going to talk about those programming concepts in detail. So if you don't know any programming, then there are probably a lot of things, a lot of unfamiliar terminology over there, or even if you know the words, they probably have a different meaning than what do you think they mean in the concept of programming? Anyway, during these first 7 weeks, we basically cover like the fundamentals of writing computer programs, and then we continue from that in the advanced course. Before we get into details, important practical thing: if you have previous programming experience with Python, and if you, and I mean like you really have previous experience, not just that you've written like 1 or 2 programs, but you actually written programs with Python, and you haven't completed this course in MOOC.fi, and you haven't completed a similar course in any other Finnish higher institute, then it's possible that you can pass the course with initial exam. And the whole idea is that if you know this stuff, there's no point in learning it again. So you can spend your time more creatively, and also I don't need to assess your exam because you already know stuff. Anyway, so if you think you know it, you can take the initial exam, and the exam, it's an online thing. It happens this Friday at 12 o'clock. And if you want to do it, you need to register by email before tomorrow morning, or by 8 a.m. tomorrow morning, and just write me an email and just say that you want to participate in the initial exam. And the deadline is strict. I will be away. I'll be on a trip starting later tomorrow, and I won't be back before next week, so I won't be reading my email during that time. So if you haven't registered by 8 tomorrow, then you can't take the exam. So anyway, if you have any previous experience, please take it. It's probably the best idea to pass the course, but as I said, it's only meant for people who actually know stuff. So if you've done a little bit programming and if you're wondering whether you may pass it or not, then you probably won't. It won't be an easy exam, but if you know the stuff, then again, it won't be a difficult one as well. Okay, then what do we mean by programming? It's about writing programs using a programming language. And why do we write programs? It's basically to solve different kind of problems. That's what writing programs is, typically problem solving, and then the problems can be basically about anything. And why do we need to write programs? You all heard a lot of discussion about artificial intelligence, I think, and things like machine learning, and there are a lot of sort of interesting applications. There's I don't know if you've seen, but it's sort of a lot of, for example, these AI powered things online now, where you can generate a sort of like a painting or a song or a poem by AI by just giving some keywords, and those are sort of fascinating. But still, even if we talk about intelligent systems, computers are quite stupid. Computers themselves are not intelligent. However, the computers are really great at executing simple tasks repeatedly, so they can do a lot of simple operations each second, like billions. And by those simple operations, when we combine them creatively, we can construct solutions to rather complex problems. And so programming can be a great tool for solving problems that are difficult to solve by any other means. And I'm going to show you an example. And this is something I've been doing rather frequently, but we have a research group that's sort of interested in mathematics learning of kids. And we have a lot of data, and the data is basically about the calculations solved by students. And there's a lot of that data. There's like, I think, millions of lines of data. What the data sort of looks like is something like this. Is only part of each line, but there's like a type of calculation, and then the actual task, and then there's a lot of data about that, and there's going to be a solution, and like the solution, and whether it was right or wrong, and things like that. And what was needed is to filter out a specific kind of calculations from that whole list. So things like find all subtractions where the first number is less than 21 and the second one only has 1 digit, which is sort of a simple problem to solve by any human if you don't have a lot of data. So, for example, these calculations would be suitable for this specific task because 11 is less than 21, and the second one only has 1 digit, so it's 11 minus 6 or 90 minus 4, but these need to be filtered out. 24 is not less than 21, so this doesn't do, and for the second one, 11 doesn't only have 1 digit. And what the research group was trying to find out was how are the students performing on certain type of calculations. And as I said, there were more than 250,000 lines per file, and there were 20 files, if I remember correctly. So that's like 5 million lines of these calculations. So it's really difficult to do by hand. You don't want to go through 5 million lines 8 times. You don't want to do it once, I think. It's sort of difficult to do with existing tools as well. If you try to load it in the Excel, there are way too many lines, and it's not that easy to filter out the specific lines and so on. So I wrote a Python program that performed, basically filtered the 8 different kind of tasks from all files. So what it did is it read all those 5 million rows, and then it split it into 8 different files, where each of those files contained only the desired kind of calculations. Writing and testing the kind of program took something like, I think, around 30 minutes. So it wasn't that long. And I think handling all 5 million rows of data for all those 8 tasks took something like 30 seconds or something. So what I'm trying to tell you with this one is that some problems are really sort of straightforward to solve with programming, and this is also the kind of problem you will learn to solve in this course. So after completing the introduction to programming, you should be able to write a program that performs this kind of task. You probably won't be filtering any learning analytics data, any mathematics data. You might, but I think it's sort of, you probably won't, but you are probably going to do something similar at some point, whether it's for your thesis or research or doing something, whatever. But at some point, you probably will have a lot of data where you want to get, or you want to manipulate that data somehow. And that's what computer programs are really useful. You can do a lot of things with computers. That's just one example. But I think it's a good example because a lot of people encounter these kind of problems and these are really easy to solve by just typing a simple computer program to solve it. So the language we are using is called Python. It's a translated programming language. There's a little bit theoretical background for this into material, although the material is mostly supposed to be sort of practical oriented, meaning that it's mostly about writing programs, but there's some theoretical background now here and there. Anyway, translated programming language means that when you have a Python translator running in your computer, it translates the program one instruction at a time to the form which the computer can then execute. And the upside for this is that when you write a Python program, you can execute it in any computer that has a Python translator. So basically, it means that one Python program you have written, you can execute it in your Windows computer, or in your Mac, or in your Linux computer, or in any servers, or in most mobile devices or things like that. So you don't need to write separate programs for different environments, which used to be the case in the old days. Python can be used for various purposes. We are only going to cover some of them, but it's, for example, very popular in artificial intelligence and machine learning and biotechnology, to name a few. I think most of the artificial intelligence or machine learning applications are written using Python. It's sort of a powerful, there are more powerful programming languages if we think about just the performance, but then the performance isn't only about how quickly a program is executed, it's also about how easy it is to write a program. And in that sense, Python is a great language because it's easy to learn. The syntax is really simple, but still you can do a lot of things with it. It sort of depends on who's measuring it, but Python is at least in the top 3 of the most used programming languages at the moment. Some say it's the most used one, and some say that there are some languages like JavaScript or Java which are used more, but I think Python in many ways is in top 3. Regardless, it's used quite a lot in the industry as well. But what I think is great about Python is that you don't need to be a programmer or software developer to find Python useful. You can do something entirely different and still use Python as a tool to write like simple scripts to solve problems, which, as I said, which might be really difficult to solve by using any other tools. So what will we do in this course? How do you complete it? There are 2 main components. There are the shared sessions. It's Tuesday at 12:15, and then the more important part is the one where you complete the exercises in MOOC.fi. I will show you it in a minute. And then at the end of the course, we have a final exam, which I will also discuss a bit later today. If we think about the workload, and I think it's important to think about the workload, you have other courses you need to complete as well, and other things you're working on. It takes a lot of work to learn to program, especially if you start from knowing no programming at all. And a lot of you start from that point, and that's perfectly fine. That's how the course is designed. It doesn't matter if you have any previous experience, but you don't need to have any previous experience in programming to learn it by using this stuff. But if you think about the workload required, I think something around 10 to 20 hours per week. If you have some previous experience, but maybe not enough to pass the initial exam, you probably will complete at least the first weeks faster. It may only take like a couple of hours. But then if you don't have any previous experience, it may take some time. Anyway, what I'm trying to say here is be sure that you have enough time to complete the course. Please just try to clear your calendars. Have at least 10 to 15 hours each week to work on the exercises. At least as long as you find out how quickly you're learning stuff. There are a lot of differences in here, but I think the average time needed per week is somewhere from 10 to maybe 15 hours per week. Okay, now all course material can be found in one website, and please write this down. This is also listed on the course page, in the Helsinki course page, if you take a look, but this is the only thing you need to write down on this from this lecture, programming-22.mooc.fi. And if we take a quick look at the material, this is like the front page, there's all the basic stuff. We're going to talk about a lot of these today, but there's like support channels, the timetables, the lectures. There are the recordings from last year's lecture, but I will be providing these updated ones here after each lecture. There's things about grading and exams. There's more about support. There's a frequently asked questions, which is a good idea to take a look at before you ask questions to get the answer faster. So, I mean, it's not about, you can definitely ask any questions you want to. That's really okay. And then there's the actual stuff. And what I want you to do after this lecture is to start from part 1. And you just start reading the material, and then just log in. I hope you participate in the research, but I won't, because so for the first 3 weeks you don't need any external Python editor. You don't need to install anything in your computer as long as you have a browser. And if you're using Mac, it might be a good idea to use a browser different to Safari, because there has been some problems before with that one. But the basic idea is that for the first 3 weeks, the exercises are attached in the material, and I can just type the program in here. There's what you need to do is written above here. And I can type something, and when I click the run button, it then displays the output of my program. A little bit larger. And when I click the test button, it finds out whether my answer was correct or not. And then you can try any of these exercises as many times as you want to. Let's complete this one. We need to output an emoticon like that. And when I test it now, it should be, it takes a while because it submits in the server, and now it's completed. And when I completed it, this bar here goes green, and then you can see that I collected the point available over there. And then I can just continue and keep on writing and fixing and running programs. And as I said before, you can try any exercise as many times as you want to. And that's how we write programs in real life as well. So we type a program, we test it, then we fix it if there are any problems, and then we keep on doing that. And that cycle goes on and on until at some point the program does what it's supposed to, or at least is as close to that as possible. So as I said, we have tried to write this first material so you don't, it's easiest if you just start doing it by yourself. So that's why I'm not talking about any actual programming stuff in here. That's a bit abstract before you know about anything. But when you start doing it yourself, then you get started, and then you go on until you reach the end of first page, and then you can go to the second one. There are 5 pages in the first week's material. And then at the end of the 5th one, there's a small, excuse me, small survey about what things you did learn, what things remain unclear, how would you improve the material, and how difficult you found it, how much you spent time, and how would you grade it. And please answer this one as well. You get 1 point for answering it, but also it's really important that I know how you felt the material was, and so that when we are developing the material further, we know if there are things like that are too difficult or too easy or so on. And if you have had any specific problems with any of the exercises, or if you think the material didn't cover some of the things good enough for things like that. So this is like your direct channel to me and to other developers of this material to tell us how you felt about it. Okay, so everything you need is over there. Then, as I said before, although you complete the exercises independently, meaning that you don't copy anyone else's answers, you don't need to complete them alone. You can work with other people if you know any people. Other people from this course, it's perfectly fine to work with someone. And I think even more important is that if you have any problems, you can ask for assistance in workshops and in Discord. And the detailed information is found in MOOC.fi. The workshop times will be updated. Let's see. I don't think they are there. Oh, they are here. So here are the workshop times starting this Thursday. So these times aren't available this week, but Thursday. And so there are times which are only where there are instructors only available in Discord, but then there's also these campus times. And meaning that in Exactum, the class BK 107, you can go there, bring your own computer, and then there are instructors there who you can discuss to. I'm there myself sometimes, and you can ask for help with any of the exercises or in more general about specific topic or whatever you want to. And we are updating this table constantly. So before you go to campus, if you're just going for that, check that the time is still available. And the reason we update it is, of course, if there are times when there's no one there, no one requires any help on any specific time, there might be like a lecture at the same time or something, then we're going to move it to some other location or some other reschedule it to some other time. So basically we try to give you assistance so that it's convenient for you. There's no point in having these sessions if there's no one there to ask for any help. The Discord, I can also show it to you. There's a link for that in the material. Well, here, for example. Looks basically like this. If you've used it before, then you know how it goes. If you haven't, it's not that. So you can just write any message in here. So if you're having problem with any of the exercise, just ask your question here. And then there are some specific times when there are instructions available. Even on campus times, there usually an instructor in Discord as well, if it's not too crowded in the classroom. But then there's also specific Discord time. But the Discord also works sort of as like a 24/7 forum, in a sense that you can ask your question anytime. And there are, in addition to instructors, there are a lot of other students over there who can help you as well. So feel free to ask anything, and it's been working really well, and it's okay to ask anything programming related, that is. So don't think too much about whether your question whether it's like too simple or whether everyone else knows this stuff or things like that, because that's not true. If your question is something it's definitely okay to ask it. Ask whatever you want. You don't need to use your real name in here. You can just come up with any nickname so it should make it easier to ask any questions. I'm there with my own name, and so are the instructors, at least some of them. Well, it seems I'm the only one online right now, but there are a lot of other people over there. So even if there are not like the official instructors, someone can still answer your questions. And also, if someone is asking a question and you know the answer to that question, it's perfectly fine to answer the question as well. That's how it's supposed to work. It's like a peer help kind of thing. Anyway, don't provide like if someone is asking something, don't provide a working program as an answer. Just try to provide something like some kind of instruction or hint on how to move forward towards the solution. Anyway, you get the point when you follow it for a while. Okay, Then if you think whether programming is difficult or not, then I think for most of you, it may appear to be difficult, at least, or at first, not at least at first, but at first. And the reason for that is that programming is really different to probably anything else you've done before. It's not mathematics. Math is important in some areas of programming. If you think about things like artificial intelligence and machine learning, there's a lot of mathematics related to those programs. But then again, there are some programming where mathematics doesn't really play that big of a role. And programming really isn't mathematics anyway. There are people who are great in mathematics but don't really know anything about programming. There are great programmers who aren't really that good in mathematics and so on. It isn't logic, pure logic either. There are some logic is definitely useful in programming, and there are some logical constructs in programming, but programming is sort of difficult to, I'd say, any other skills, at least any other like common skills. And for that reason, it may seem difficult at first, and it actually is difficult at first for most people. And that's why I hope you don't get frustrated at first, because most people, when you keep on going after a couple of weeks, you see that you're starting to get the point, and it becomes easier gradually. Now, the programming education, there's a lot of research about that one. I've been doing some myself as well. And the one thing in common for most research is the fact that it emphasizes the importance of active learning. So as I said before, I don't think anyone has ever learned how to program by just listening someone talking about programming or watching videos, but you need to actually actively write programs yourself and keep on writing programs until you solve those tasks one at a time. It's in that sense, it's actually quite close to mathematics. So if you think about how you learn to calculate it was first like basic addition, you need to do it yourself. You don't learn mathematics by just listening someone talking about mathematics or watching someone perform mathematics on a whiteboard or anything like that. You need to do it yourself. You need to perform those calculations by yourself. And the same applies to programming. You need to write and that's why you start by writing your very first programs in the very beginning of the first part. It's like there's a couple of paragraphs of text, and then you need to write your first program. And that's how it proceeds from there. Learn things really like small part of the time, and then you test them yourself. Then you use the things you just learned, and then you move on. And you also build on the existing knowledge all the time. So that's like the nature of programming. Okay, we talked about the TMC. This is the environment this MOOC.fi is using, this TMC platform. Something important is that, as I said, for the first 3 weeks, you don't need, it's not necessary to have any like external editor, or you don't need to install Python to your own computer. In part 4, basically like 4th week, then you're going to install an editor called Visual Studio Code on your own computer and a Python interpreter. Those are free tools, so you don't need to pay for those. And then starting from the 4th week, we're using those to write your programs. But for the first 3 weeks, you don't need any external tools. You just need your computer and the browser and the internet connection, and that's all it takes. To register to the material, you go to this, you'll probably type it down already, programming-22.mooc.fi, and then there's a register button here, or it asks you to register in the beginning of the first part. If you're a student in University of Helsinki, use the email provided by university and add your student number in your details. This makes it a lot easier for me to register your grade later. If you're from Open University, if you're not a student, at Helsinki, then you can use whatever email you want. We can still register your grade, but it's a bit more complicated for me, so it just makes my life a little bit easier if you use this email and your university student number. And also, if your university student, remember to register the course in Sisu if you haven't already. We can't assign you any credits if you haven't done this. So you enroll into course or whatever it is in English, the term. I think most of you probably done this. If you haven't, just do it after this lecture or something. This isn't actually true now. We have published all the materials. There are no weekly deadlines, so all material closes at the end of the year. So if you take a look, there are actually all 14 parts are available at now. This also means that if you're really quick, you can complete the first 7 parts in less than 7 weeks. I sort of recommend that if you don't have any previous experience, then 1 part per week is that's probably the way to go, but there's nothing stopping you or doing this more quickly, or there's nothing stopping you in using some extra time to complete them. Just make sure that you complete all you need to before the end of the year. So this whole course closes at the, I think it's January 2nd or something like that. And what you need to pass is you need at least 25% of points from each of those parts. So from each of these 7 parts in here, at least 25%. You can see your score board when you click this. Click this one, you can see that I haven't been doing that great in here, but this shows your how well you proceeded. So in programming exercises and in total points, I need to get at least 25 from each of these parts 1 to 7 to pass the introductory part. And I strongly recommend that you try to complete, that you don't settle for 25, but you try to complete as much as possible from each of these parts. Aim for 100% in each of these parts. The fact is that if you complete all of these 7 parts with 100%, at least close to 100, the exam will be really easy. You don't have any problems in completing the final exam. You will know the stuff well enough. So at least in the beginning, try to complete as many exercises each week as possible. So to pass the course, you need at least 25% of all points from each round or part, and then you need to get at least 15% of the final exam score, sorry. And how your grade is, how you get your grade, 50% comes from the MOOC points, the points you're completed in the material, and 50% comes from your exam score, and then those are combined. And then if you get more than 90 of the all available points, you get 5 as a grade, and if you get less than 15, then you fail the course. So it's really simple. This also means that if you only complete the minimum amount of points of 25 points, 25% of the MOOC points, you can't get a grade higher than 3, regardless of how you do in your final exam. So half of your final grade comes from those exercise points in MOOC.fi. So from that point of view, also it's a good idea to try to complete as much as possible from the beginning. Then there are 3 exams. The dates are announced in the material. Some of them actually are, and there will be more. If you take a look at the first exam, which is sort of meant for you, is October 25th. There's an exam coming on October 1st, but unless you have a lot of previous experience, I sort of don't recommend on taking that one. But this one is perfect. It's like 1 week after the final lecture of the course. And then there's one coming in, well, there's one date after that one, and there will be at least one date after that one announced later. We're going to announce it when we see how many people there are who require more exams, but the final one will probably be in January. something like the second week of January or something like that. Anyway, it will be included in this list later. You do the exams electronically with your own computer. So taking the exam is really similar to taking the exercises with the material. Basic idea is that the exam is open between 10 in the morning and 10 in the evening. And during that time, you can take the exam whenever you want to. It takes 3 hours and the time starts rolling when you start the exam. You can attend as many exams as you like. So if you're not happy with the result of your first exam, then you can take more exams. More exams later, your best grade is the one that's counted. So you can't get worst grade from any of the subsequent exams. Exams are unlike all the other material. You need to work on it alone. You can't communicate with anyone. Even though you're doing it in your own computer, we are checking things like if there are students with two similar answers, then it's perfectly possible that you will be failed. So you need to work on it on your own. Anyway, as I said before, if you complete all of the exercises or most of the exercises with the material, the exam is going to be quite easy. Okay, any questions about these practical things? There's a lot of stuff I talked about today, but all this stuff is also found in the materials, and this lecture will be provided. The recording of this lecture will be provided later. Okay, there's one final thing. This is a practical thing. There won't be live lecture next Tuesday, unfortunately. The recording is already over there, so you can take a look. It's from last year, but the topics are still all valid. Unfortunately, there's a trip I need to take. There's nothing. I tried to move it to a different time, but I need to take it, and I'm leaving tomorrow actually, and I won't be back until sometime next Tuesday. So I probably won't be back in time to give the lecture. So this is the only exception. I will be giving all the other lectures live. So you're going to see me in live form in 2 weeks on September 20th. But if and when you have any questions, please use all those channels we have provided. Use the Discord. You can send me an email and so on. So this is an unfortunate exception, but as I said, there was really nothing I could do about this one. Okay, I'm going to